Welcome to all for the course Internet of Things. This is a series lecture on Industry 4.0 and Internet of Things is IoT, which is a required branch of Industry 4.0. So, the Internet of Things is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with a unique identifier and the ability to transfer data over the network without requiring a human to human or a human to machine interaction. So, Internet of Things is a concept of connecting any devices to the Internet and to other connected devices. The Internet of Things is a giant network of connecting things without the people or from the data and taking the factors of the environment around them. The thing in an Internet of Things can be a person with a heart monitoring implant, a farm animal with biochip transponder, an automobile that has built-in sensors to alter the driver when tire pressure is low, or any other natural or man-made objects that can be assigned an IP address and is able to transfer data over the network. So, in brief, that is, IoT includes the extraordinary number of the objects of all shapes and sizes for a smart microwaves, which automatically cooks your food for a right length of time, to self-driving car whose complex sensors detects the object in their path, to variable fitness devices that measures your heart rate and number of steps you have taken that day, then uses the information that has been obtained from the sensors to suggest a exercise plan tailored to you. There are even connected footballs that can be tracked how fast and how directed towards the goal the ball travels. So such the informations IoT collects as a data, and these data are being manipulated and maintains or controls the machine. Now we'll see the major components of IoT. IoT consists of very broad sense, because any mission, for example, we are just going to implement this IoT in a working machine. Okay, let us take a example of a milling machine or a turning lathe. So when a milling machine has to operate by itself, okay, it needs to be connected, or it has to be connected with the net. Okay, through the net it has to go through the gateway, it has to reach the particular sector of the cloud computing, take a big data assistance, and then it has to run the machine without the intervention of the human. So in this setup, the major components of IoT are the things of devices as shown in the figure, and the gateway. So the transfer of data from the things of the device, which is nothing but the physical sensors. Okay, normally whatever that captures as a input data is called as a thing of device, that being transmitted to the through the network into the gateway, and from the gateway it takes the assistance of the cloud computing, and from cloud computing it gets the data manipulations and analytical processes and being delivered as output through the user interface. So these are the 5 components which is termed to be a major components of IoT. So let us come to the brief understanding of the application and the usage of IoT. So IoT not only used in industries, okay, it is basically used in all physical devices or all daily usage devices, right from usage devices to the space equipments. So some of the usages or applications are being termed here, listed here. First is a smart home, wearables, and smart city, smart grids, industrial internet, connected cars, connected health, and smart retail, smart supply chain, and smart farming. So these are some of the applications which has been extended beyond its own, ranging from autonomous vehicle to the space engines. Okay, so everywhere this IoT plays a vital role in controlling the entire system without the intervention of the human. So next, we'll just have much more understanding on IoT in a very simple sense, like IoT at a home. How I told that IoT has application in a smart home. So in a home, for example, let us take, imagine you wake up at 7 a.m. every day and go for work. Your alarm clock does the job of waking you just at 7 o'clock. It's fine. Okay. That is until something goes wrong, your train cancel, okay, and you have to drive to work instead. That is, you have to take a car instead of going in train. Then your only problem is that you have to wake little earlier, because driving in a car to reach your workplace will take much more time. That is 15 minutes extra. I think it means that you have to wake up by 6:45 a.m. Okay, so a connected or IoT enabled alarm clock would reset itself based on all these factors to ensure you got to work on time. It could recognize that your usual train is cancelled, calculating the driving distance and the travel time for your alternative route of work. Check the weather and the facts, because maybe due to rain your travel speed may be reduced. All this has been calculated, all these factors have been taken into consideration, and your working alarm has been set in such a way. So this is what IoT is. So there is a vast difference between automation and IoT. When we say about automation, automation is nothing but what we instruct as a program or as a setup. It will does what we instruct to the machine. Okay, for example, I set an alarm at 5 o'clock, it will ring. It is automatic. Okay, but IoT is a little different. Okay, like it understands the environment, and by understanding the environment, it will react. Okay, to understand the environment, it has to be connected. Okay, so that fact is here IoT. I hope you have much more understanding. Let us go in deep understanding about this IoT. Having been worked by your smart alarm, you are now driving to work. On coming the engine light, okay, you had rather not head straight to the garage, but what is it? Sometime something urgent. Okay, in this connected car, the sensors that triggers the check engine light would communicate to with the other in the car. Okay, for example, the component called the diagnosing bus collects data from these sensors and passes it to the gateway in the car, which sends the most relevant or most urgent needs to the manufacturer's platform. Okay, in most of the cars we have that. Okay, any problems which is being identified even in a running condition of the car, it will be transmitted to the fixers, okay, or the manufacturers, and they will alert the owner of the car or the driver, and they will direct them to go to the nearest workstation to replace it. So such thing is called as a IoT platform. So to have a much clear and most known understanding of IoT is the world with online and communicating to serve the people that enhances our lives. Okay, that is IoT. For example, a self-driven drone delivering a grocery. Okay, order to sensors in your clothing, monitoring your health. Okay, likewise, world undergo a technological shift, which is termed as a Internet of Things. Okay, because you understand how much important IoT is. A basic premises and the goal of IoT is to connect the unconnected things. Why to connect? To make it understand and react, to take decision of its own without the intervention of the human. So IoT is a technological transition in which the device will allow us to sense and control the physical world by making the object more smarter, more intelligent, and more compact. So let us all, we are all been talking about IoT. When it been emerged? Actually, this concept of IoT was emerged in the year 2008 to 2009, and it was being coined by Kevin Aston. Okay, he is a person who has coined this word Internet of Things. So while working for Procter and Gamble, Kevin in 1999, he has faced this word to explain a new idea related to linking the company's his own company with the supply chain to the internet. In the 20th century later on, the computer's brains are just essence. It will do what we have instructed as an automatic machine. But later it picks up, okay, starts to decide and to inform and predict most of the things where the IoT come into full-fledged in the 21st century in the actual scenario. So here is a slide. Here is a slide where it will show you about the evolution of the Internet of Things. Actually, the Internet of Things was been grown from the connectivity. You know, the connectivity, how a people to people has been connected. In the earlier stage, we call it as a digitized access using a email and a web browser and search. Okay, these are the connectivity where we started. And later in the 19th century or 20th century, the network economy, that is transfer of the data, okay, from one system to the other through LAN and WAN. Then comes the immersive experiences like social, mobility, cloud, video. All this have been transmitted across the internet and reaches the customers. And later in 21st century, and now we are into the Internet of Things, where it connects the people, connects the machines, and transfers the data, things, and everything, and takes its own decision as a human being does. So this is what has been the connectivity. Connectivity, this phase of connected people to email and network economy is like, as I said, this phase enables the e-communication, e-commerce and the supply chain and so on, like we reach to the Internet of Things as of now. So the first phase, the connected phase was being developed in 1990, as I told you, and the second phase, which is the internet evolution, like the network communication, was being get into the market and increase the marketability, particularly the industrial growth and the manufacturing sector. Later in the third phase, like immersive experience, almost reaches all the world what is happening all around the world. So there is nothing like we say about globalization, which has been established in this third phase with a very high height. And then the fourth phase, what we call it as the Internet of Things, comes into the 21st century and takes all over rules over the industry. Now there are also challenges what we have to see see in the as we show in the slide. The challenges are like scalability. For example, I have a small IoT which has been fixed to one machine. If I go and add 2 or 3 machines, then it is not possible for me to have that one router or the scale of instruments can be used for other machines also. So there is a problem of scalability, one thing, and a lot of data. Okay, there is constraint of data has to be transferred. That is also will be a problem. Okay, which has been nowadays it has been rectified by using a high optical cables and speed internets and other things. The second challenge is what we face is the security. Okay, because every company or every mission needs its own data, or a company needs its own data to be secure. Okay, but we are in IoT, we are going to pass the data through the net, where the security is the greatest problem. But anyhow, the other cyber security and the protections have been given and ensures that the data are not being missing, and hence the industry 4.0 has been reaching its own height. The third challenges is the privacy. Again, the same concept. It has to be really the company has to believe that their privacy is being sustained and maintained, not being leaked in the internet. So the fourth is big data and data analytics, because as I told you, we exchange or interpolations of a lot of data have been happening across the missions. So it has to be taken in a right sense, and the interoperability is the next important challenge. But in nowadays it has been clarified and been checked, because the interoperability is the important concept. We have to understand that interoperability interoperability is like one if I send a message from one engine, okay, from one system, and it reaches to the other system, both the system that reaches the data should also understand the what data is being sent. For example, if I send the information from one platform and it reaches the other computer in another platform, it has to be reachable. Okay, it has to be readable, sensible, and it has to be reactable. So that concept is called as the interoperability. Now, the main elements of IoT, okay, that is so important, because later we will also see about the architecture of Internet of Things. In this, the main elements, what we have seen is the main components. Here, the main elements is like the server layer, service layer, and the network layer. Okay, this is what been the broad sense of this particular information. Like in application layer, we have a smart energy, home applications, energy applications, so on. Likewise, in a server layer, there is what are the architecture? Okay, the main architecture what we use is M2M. M2M. It's a machine to machine. Okay, where machine controls a machine. That is what being aimed. No intervention of human is required. Okay, that is the architecture. The main architecture, we call it as a service layer, and then comes the network layer to take data from the cloud computing, to take the data from the sensor, okay, physical devices, and to take the required data from the big data, and the one which is being shown over here, that is the interface, user interface. That is what so important. So the next is very important, what I told you, because in this concept the layers of IoT is so important to be understood. There are certain layers of IoT, okay, because the IoT is not only taking information from the machine, collecting the data from a machine, okay, it is something else where the data taken has to be manipulated, okay, and it has to be managed, okay, or it has to be manipulated so that we come out with the required output. For example, I walk out of us house, okay, and the temperature outside is like 45 degree, and when I come inside, okay, before I come inside, my AC should on 5 minutes before, and the temperature should be set. If 45 outside, then it has to set like 22. Okay, if it is 40, then it has to set as 20. Okay, you understand the situation. So this all can happen only with IoT when it is connected with my AC. Okay, and the active my phone should be also connected. So my phone will read the location, will take all the temperature, it will send to that, and that will take a decision, and it will keep me comfort air conditioned system when I enter into the house. So this coming back to this slide, the first layer is the physical device. It's nothing but taking, okay, sensors, okay, or any other camera. Even camera can be a physical device that takes the input. Okay, for example, I told you like what is where I am going, my location, and what is the temperature over that particular location. All this will be taken by the sensors, okay, or a camera. So for example, if you want to get into a place where a door closer, automatic door closer is there, and you have a face recognition system, the face will recognize to you first, okay, it will take a picture when you stand before the camera, and this picture will be taken back to the system, and it will compare whether you are accessed person. If you are allowed accessible person, then only the door will open. Okay, so the first phase is your physical device, it's nothing but the sensor. The second device is the collected data has to be transmitted. Okay, as we have seen in the second phase, the data transfer from one that is physical device to the other devices through the wire or through wireless, okay, through a router. That is the connectivity. Next comes the fog computing or edge computing. Okay, the fog computing or edge computing is a very essential process or a layer where it filters, okay, all the unnecessary things and gives only what is required. For example, if I stand before a camera in a recognition camera, okay, well, it will take all my surrounding apart from taking my own face. So what is the back is not required for the data to be compared. So it will filter all the unneeded data and it will take only the required data to the next level of thing. So that is one of the fog computing. Fog computing is really important process which we will be discussing in the next slides. So likewise, the next phase, fourth phase is your data accumulation, where all the data which comes are being stored on a platform, and then comes your abstraction. Okay, all the data will be given a number and it will be shorted for the later pickups. And the sixth part is so important, application, where the data from the cloud computing, big data, everything will be compared to get analyzed. Okay, analyzed the process of your data. So whether I can open the door or not. Okay, that is the example what we have been discussing. Likewise, or what is the temperature I have to set based on the other location. Everything here in the application only, it will be taking the cloud. Cloud will give what is the exact temperature of the outside and how much time it will take for the people to come inside. All this will be done in the application layer based on your what is your current temperature inside the room. Everything will be taken over there. And the last and the final layer is called the collaboration and the processing layer, where the output, that is interface, okay, the user interface is being connected, or a controller where they, like as I told you, opening the door or setting the starting the AC and setting the temperature. All this will be done in the last layer. So this is so important and being discussed. So the first layer, as I told these things, the connectivity is also again an important thing. The communication between the layer one and the devices, reliable delivery of information across the network, switching and routing, and the translations between the protocol network and all other things. As I told you, the edge computing. Okay, the edge computing at this layer, the emphasis is on data reduction and converting the network data flows into the information that is ready for storage and processes by the higher layer. One of the basic principle of this reference model is that the information processing is initiated as early as closer to the edge of the network as possible. The another important function that occurs in layer 3 is the evolution of the data and also filtering. Okay, as I told you, filtering and the aggregation aggregated before being sent to the higher level. So the edge computing is also like taking the raw data, making it manipulated or usable data. Okay, converting it into a usable data is called as the edge computing. But fog computing in general is, for example, it is mostly related with cloud computing, because every cloud will have a fog node, and this fog node will be connected directly to your user. So every user, okay, we call it as edge because it is the edge towards the user. Every user will be given a fog node, and because we can't just go into the cloud directly, it will take time for us to search. So this fog node will make our work a little easier, and the same thing is being done over here in the IoT architecture. Next is like the fog computing. The examples like including the industrial control switches, routers, and the embedded services and IoT things. So to define the fog computing, we have the following contextual location awareness and geographical distribution, deployment near IoT endpoints, and wireless communications between the fog and use for real-time interactions. Okay. So let us come into the simplification of IoT structure. The framework is presented in two parallel stacks. Okay, like one is called as a core IoT and another is called as the data management and compute stack. The core is like first three processes, and the next IoT management sector is the other four. Okay, for example, first four layers, three layers are called as a core, and the next four layers are called as a IoT management stacks. Okay, so the network communication layer of IoT stack itself involves a significant amount of detailed and incorporates a vast array of technologies, considering for a moment the heterogeneity of the IoT sensors and the many different ways that exist to connect them to the internet. The network communication layer needs to be consolidated. These together offer a gateway and backhaul technologies, and ultimately brings the data back to the central location for analysis and processing. So the network between the gateway and the net data center is composed mostly of traditional technologies that experienced IT professional could quickly recognize. Okay, that is due to the unique challenges and requirement of IoT. It is often necessary to deploy application and data management through the architecture. Okay, so in general, the three data management layers, as I told there, like edge computing, almost the fog computing, okay, where everything works related to the data management. Okay, so edge, fog, and cloud. All this is a layer where it is work for the data management and analytics. So the expanded view of the simplified IoT is like the first sector, core sector, okay, is being connected with the physical devices. Okay, that is what being told. Like I take things, I need things to manipulate. Okay, so first sector which shows the IoT network management. Okay, like network transport layer and gateway and the access network. All this is connected with the communication network, and this gives the interaction from the cloud, fog, and edges, and give the processes or gives the end products using the application to the vertical specific applications like SCADA, MDMs, etc., and analytics. Okay, so the IoT data management and computer stack. Uh, the data generated by IoT sensor is one of the single biggest challenge in building an IoT system. In sensor network, the vast majority of the data generated is unstructured or and of very little use to the its own. Okay, in most cases, the processing in location is outside the smart objects. Okay, like natural locations for this processes activity is in the cloud. The smart objects need a connect to the cloud because to take a data, we need lot of data to be taken. So the cloud and the data, big data plays an important role in IoT thing. So in general, or the summary of this IoT data management and computer stack with fog computing is like a data center where it is being connected with your core, and this core take a fog node or a fog layer, and then it reaches with the particular smart object. So the devices and the gateways. Okay, this is a growing market for a small scale embedded processors. Such devices enables very constrained devices with a full footprint of the few square, and with a very low power consumption in a milli to micro watts range. Okay, but which is capable of hosting an entire transmission control protocol, that is TCP/IP stack, including the small web servers. Okay, a device is a hardware unit that can sense aspects of its environment or actuate, that is perform task based on its environmental condition. The devices can be characterized as because the device is nothing but your physical device, okay, and also your end device, the sensors and actuators. Those are the devices which are very essential to take the input data and to act according to the output. Okay, that is the thing. So the gateway is again the network what we are speaking. The network should be very high because there's no point in saying that I don't have a proper network of 5G or so. The industry 4.0, which depends on the technology, okay, and the full-fledged technology will give you a proper network facility. So next architecture, what we need to understand, as I told you, like M2M. M2M stands for machine to machine. Okay, communication. It is first used in a European Telecommunication Standard Institute, that is ETSI, created by M2M Technical Committee. Okay, and this is exchange, how this manipulation or taking of data done and coming to the user interface have been done by this one of the architecture. So the goal of one M2M is to create a common service layer which can readily embedded in field devices to allow communication with application servers. Okay, like M2M framework focus on IoT services, applications, and platform. One of the greatest challenge in designing of IoT architecture is dealing with the heterogeneity of the devices. Okay. So it is like one M2M on a horizontal framework and RESTful APIs allows the LoRa WAN, okay, which is yeah, LoRa gateway is mostly used in transmit sensors data from the electrical device to the cloud. So, and the other devices or the other architectures that promote end-to-end IoT communications in the consistent way, no matter how heterogeneous the net networks are. So, to have a inference or to see the actual matching of M2M with IoT is the M2M is a point-to-point connectivity where the network is not like that. It can be connected with all the possible connected parts like the cloud or any other devices like the data centers, everything. Like M2M have many devices connected to network. Here only one or two being which need to be accessed being connected in IoT. For example, machine 1 is connected directly to IoT and machine 2 likewise because it needs a separate control, okay, output control. Likewise, M2M designs for a small scale, whereas IoT, I already told, we are going to run a full industry. Okay, here M2M is not like that. One particular with all actions. Likewise, M2M devices do not allow need to be connected internet where it needs a continuous internet. So let us just go over the managing of M2M data. Like data flow from a moment it is sensed to the moment it reaches the backend system has been processed and manifold. The dealing with M2M data may be decomposed into several stages. Additional degree of focus in each stage heavily depends on the actual usage requirement put upon the data as well as the infrastructure. Hope this information regarding the IoT will give you a much insight, okay, because this series of lecture is based on the Industry 4.0 and it will give you a much basic understanding of how IoT plays its vital role in the establishment of Industry 4.0. Thank you for your patient listening. Thank you all.